There are some Taylor and Maclaurin polynomials that are very common for functions that we deal with. So what we are going to be able to do is use them to actually create some other Taylor polynomials. So at the end of this lesson, you'll be able to use a Taylor-Maclaurin polynomial for functions using common Taylor polynomials. All right, so you'll notice we've got this nice little chart here. These are common Taylor polynomials. These are AP test favorites, so we will definitely have to know these. These are something that we'll have to memorize and actually know how to get this. All right, this is the Taylor polynomial, and since this is in sigma notation, this is actually going to give us the series. So if it asks us to not only give the Taylor polynomial, but to give the Taylor series, this is how we do it. So where these developed from was the more and more, if we were actually, and we just did the sine of x and the cosine of x, this is actually what we found when we did it. We just didn't have it all the way worked out. These were just developed from actually finding them the long way, and they're used so often that we can just memorize them and use them for other things. Okay, if you don't memorize them, you can always do the problem the long way. It's just going to take you longer. All right, and what we're going to be doing, this notice says, like this says e to the x. If it's not just x, what we can do is replace x with what we do have. And so if this says e to the 2x, we can do this same formula and we can put 2x instead everywhere we see the x. So what we can cheat a little bit, even though you can do the problem out the long way, if you don't know what's going on or you don't remember the formula, it will just make your life a lot easier if you have the formula memorized. All right, let's just do a couple examples. The first one we have is e to the x over 2, and it just says to find the Maclaurin series, and actually we're going to find the polynomial and series for the functions. Okay, e to the x over 2, since it's Maclaurin, it's centered at 0, and you notice in that chart it did say that the Taylor polynomial for e to the x is centered at 0 as well, so we're going to be all set. So basically what we're going to do, I'm just going to write down what the chart says for e to the x. It's 1 plus x squared over 2 factorial plus x to the third over 3 factorial, excuse me, plus x to the fourth over 4 factorial plus dot dot dot. Okay, so now all we need to do to actually find our Maclaurin polynomial is we're just going to plug in x over 2 every single time we see an x. So we're going to put 1 plus x over 2 plus x over 2 squared over 2 factorial plus x over 2 cubed over 3 factorial plus x over 2 to the fourth over 4 factorial plus dot dot dot. And now we're just going to simplify this a little bit. I'm going to have 1 over x plus 2 plus x over 2 squared is going to be x squared. 2 squared is going to be 4. And since we've got 2 factorial on the bottom, that's going to make 8 on the bottom. Okay, and then plus 2 cubed is going to give me 8, so this is going to be x cubed over, and 3 factorial is 6, so 8 times 6 is over 48, and then plus dot dot dot. We could keep going. All right, so that will give us the basic polynomial because we could keep going. The series then, if you recall, the series is just going to be the sigma notation. So this is going to go, I'm just going to follow that exact formula that they gave me. The other formula says x to the n over n factorial, so I know I just need to put an x in for that. So this will just be x over 2 to the n over n factorial, and I'm done. So notice on these ones, if you know the formula, the problem is extremely quick. Otherwise, I would have to actually use that long formula and start plugging things in and figuring it all out. That just saves me from having to do that. All right, let's try one more like that. Notice I have 1 over 1 plus 3x. This is actually similar to the formula 1 over 1 minus x. And this is a Maclaurin polynomial, so again, it's centered at 0. And I'm just going to write down the formula for this. This was 1 plus x squared plus x cubed plus dot 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 dot. The sigma notation for this one was n equals 0 to infinity of x to the n. So we pretty much just need to figure out what we are putting in instead of the x. If I look at how this was rewritten, if I rewrote this as 1 minus negative 3x, that's what we would have to have. So we are replacing, because there has to be a minus sign in here, so what would be in parentheses would be the negative 3x. So what we are going to do is take wherever we see an x, we are going to put negative 3x. So we're going to have 1 plus negative 3x plus negative 3x squared plus negative 3x cubed plus dot dot dot. So if we work this out, we're going to get 1 minus 3x plus negative 3x squared will be 9x squared. And then negative 3x to the third would be minus 27x to the third plus dot, dot, dot. So that would be the Taylor polynomial for that. And then if we would like to write the series, we will write it with the sigma notation. It will just be n equals 0 to infinity. And we can simply put negative 3x in for that. And there we go. So notice really it was a really fast problem if I don't have to do it without the long way, if I notice that I can use one of those common polynomials. So hopefully you can use some of those common Taylor polynomials to actually find Taylor polynomials for other functions.